failure can be hard, can be scary. In the transportation industry, when there's failures, they review it and share it not just with their organizations, but they share it with a broader community. So I'm here hoping to create a little bit of a cultural shift that let us talk a little bit about our failures, maybe laugh at them a little bit. Maybe see those failures that our friends might have also done. So a friend of mine has made all of these mistakes. And these are all fictitious friends as well. And all of these organizations are fictitious as well. Yeah, move fast and make things. Sometimes that involves breaking things. And sorry, I'm not going to talk about Kube. I don't know, maybe that'll cause some people to leave. You're welcome to walk now. This is not the talk for you, sorry. The other context I should give is that the organization I was at, we went from about 5 people on the team to about 30 in the course of 3 years. So high rate of change. Our recruiting strategy was to bring in junior, passionate, smart people and train them up. So there was a lot of learning that was going on while we were doing this. So who agrees with this statement? Serverless is stateless. I got some hands. Okay. So our first real foray was the classic hello world of serverless, which is, hey, we're going to fire up some Lambdas and do these image transformations. We're going to read in these big files from S3. We're going to store them on the Lambdas temp folder. We're going to process them. Output files go there. Everything's great, right? Has anybody tried this? Has anybody failed at this? Okay. Oh, I see one. Okay. Lambda reuses each of those instances. So when more requests come in, it spins up more instances. Those instances get hit, it can process. But if those instances stay around and are recycled to the next request, that temp folder becomes stateful. And if you leave files in that temp folder, you will quickly hit out of disk space errors. There's several ways to fix, right? You could just overwrite the same file over the time. You could clean up when you're done, or you could clean up before, or you can cycle those Lambda instances. But you got to think about what are the conditions under which this bug reaches production, right? This bug reaches production because developers are going to be testing probably low use number of transactions. They're going to have unit tests. Again, probably not that many transactions. You might have integration tests that might burst to a large load, but Lambda is going to scale up, absorb all of those transformations, and then scale back down, thus hiding this bug, masking this bug on its way to production. We fixed this, right? We saw the Stack Overflow post and we felt like a little silly and we fixed it, but we were deploying a lot, so that was good. The deployment rate on this service started to decrease from a couple times a week down and got steady, and we kind of went off and we're building other parts of the system. And we started to see infrequent failures again. And we'd go in and we'd turn on debugging and we'd poke at it, and we could never get the service to reproduce the error. There's another thing that's stateful on the Lambdas. The OS is stateful. And the OS has a file descriptor table. And the image processing library we were using has a years-old bug, apparently they won't fix, that leaves an open file descriptor in the OS. The only way we could reproduce is we had to take the Lambda, make its concurrency 1, max concurrency 1, and then we had to load test it until it failed. Then we could see that it was a problem in this library. That's how we reproduced. I don't think most CI/CD pipelines are going to have that type of testing baked in. We decided we didn't want that ongoing, but these are places that it could fail. The solution we came up with, since we weren't going to change that library, was to trigger environment variable updates on the Lambda, which would force recycling on it. We called it the self-immolation solution. It was not necessarily pretty, but it definitely worked. Okay, so if serverless isn't stateless, who thinks serverless is stateful? Okay. Well, again, this was a low traffic admin site. We had JWTs that we were just authorizing. Each microservice would validate the JWT bearer tokens. And then we want to begin to do session management, right? We want to begin to invalidate sessions. And this is incremental, so we're gonna add the session service, then we're gonna go in and we're gonna add on some of these individual API calls out of this admin site. Everything's working great until we start rolling it out to the second and third API endpoint, right? Who knows how this fails? Well, whoa, I just jumped forward a bunch. Well, yeah, Passport stores the sessions in memory, right? Works in dev and test, inconsistent in prod. Again, this is a problem when, this is a bug that can reach production when you have low use testing from your dev and your test. Integration tests weren't set up to do UI testing in this case. I don't know, has anybody tried Cognito? Yeah, we tried it and we thought it was not yet ready for production. It was very painful for us. Maybe that's a talk after we can have. Okay, so S3 is global. Who agrees with this? Okay, I agree with it as well. And we were so proud. Everything was in S3, our code, our artifacts, and we used the global endpoint. The app was built in US East 1 and deployed in US East 1, but we knew we were going to go multi-regional, so we used that global S3 endpoint so that we didn't bake the region into our endpoint. And of course, these S3 strings are everywhere, right? They are like almost more prevalent than the code itself. So how does this fail? Well, yes, S3 is eventually consistent. There was, I believe it was end of 2018 or spring of 19, there was a DDoS attack against the global S3 DNS endpoint, right? Every failure is actually a DNS failure, I think is the other corollary to learn for that. So that global S3 URL was inaccessible. It was getting DDoS'd. All of the regional S3 URLs, perfectly accessible. S3 was there, status page green, right? We've never seen that before. Totally green, yeah, everything's fine. We were stuck in this problem of we couldn't build a new version of our software because our build system relied on those global S3 URLs. We couldn't launch because all of our CloudFormation was in S3. So even if we could have gotten the code changed through GitHub and gotten all of the tests run and it deployed, we wouldn't have been able. So during an outage is not really when you want to refactor your build system or your CI/CD pipeline. So in this case, it was we were just hard down while this was out. Okay, but at least S3 has infinite read, right? Infinite read. Anybody? It's not a trick question. Okay, maybe it is a trick question. So we used a data lake, which I think just means a dumping ground to write everything. And you don't know what to do with it now, and maybe the ML people will be smart and figure out something to do with it later. So again, we just started writing anything and everything, debug output and interim output and everything. And we started dumping it into this S3 location, this bucket, and we started pointing Athena at it to read, and then visualize those results in QuickSight. How does this fail? Has anybody seen this fail? Well, Athena and S3, I think they use 429s as a flow control mechanism because they love just hammering each other so hard that S3 is going to tell it, oh, too many reads, slow down. And that's how I think Athena sizes their cluster, is literally based on what the throughput out of S3 is. And S3's throughput is going to be based on the actual shards inside of it and how fast they're able to deliver data back to Athena. At the time, how S3 was doing their auto sharding, it was prefix-based. So it would just go through the path and find the first characters in that path that had variability. And from there, it would then determine when it needed a new shard and if it could create a new shard based on the change in that character. So in this case, it was catching that day. So we had a day timestamp in there, and it was starting to shard based on day. But as you can imagine, when you're doing reporting, a lot of reports are only for a single day. So even though we internally, when we got enterprise support online, we have a ton of shards for that bucket, we were hotspotting one of them, or Athena was hotspotting one of them. Other way, we had a design principle of like, well, if S3 is down, then probably the world is coming to an end. So don't worry about that transaction, error out. We can come back and clean it up in the state machine. So we didn't have retries, we didn't have back off. Particularly for writes, this created a problem, right? So we had a lot of transactions that errored out. I would suggest for your family stability that you merge these features before your Christmas vacation, and that you then have the team disperse so that you can, I guess we're all on the internet only now, but at the time that was difficult for us. We also were using these same reports to assess the system health. So as soon as the call went out that we were having intermittent failures, everybody jumped on and clicked the refresh button on that report to see what the state of the system was, thereby making the system a lot worse. So, okay, well, S3 has replication. This was our solution to how to deal with Athena having too much read bandwidth. So we turned on replication into a second region, pointed all the reporting at that second region. We turned it down to scheduled refreshes instead of letting the user click on demand, right? So we added more graphs to the dashboard, and then slowly that S3 cost line keeps going up. And then it keeps going up. And then we keep adding more graphs, and it keeps going up. What was going on? Finance called finally and said, like, this is excessive, guys. And so then in the usage type on the billing dashboard, we realized that we had moved the data to Ohio, but we had never launched the reporting processing in Ohio. We'd left the reporting in Virginia. So we had helped Amazon with hitting their egress cost numbers for the quarter. I think the immediate solution was to turn down the refresh rate on the report so that they didn't refresh in the middle of the night or when it wasn't business hours. And so I'm not sure if my friend ever solved this one. So, okay. Well, at least it has infinite capacity, right? Maybe infinite capacity to charge you money, but maybe it has infinite capacity. Okay, again, data lake. We were going fast, writing all the things. The lifecycle policy is optional. We're still, trying to find that product market fit. We're selling to customers. We don't quite know what we want to be storing or not storing. We don't know what we want to be purging or not purging, right? That's a pretty reasonable thing. This is something we can apply later, defer it onto the backlog, do it later, right? So again, that was our S3 pathing. So how does this fail? Well, that S3 bill keeps going up, right? I think it's like some law of nature that it's monotonically increasing. We came to that there was a business need to apply a life cycle on a per type basis. Now, we thought that's fine. There's all these rules. We can just make a different life cycle for 7 years or 30 days on that type. Nope. You can only do a single star in the lifecycle matcher or matching rule, the lifecycle rule inside of S3. So we had to set a lifecycle policy on the whole bucket. But then that's not going to really help us because we're only 3 years into this journey. The longest data we wanted to store was 7 years. We weren't comfortable just growing for 4 more years until we started to cycle any of the data. So we saw that we could shift to infrequent access or Glacier or something like that. Helpfully, when you go to transition your bucket into this different storage tier, there's this nice light orange or light yellow kind of warning pop-up box right as you're going through the confirm flow, and it says there may be some transactional or transitional request charges. Luckily, the developer who was going through and doing this, the operator who was going through and doing this, was like, I haven't heard of those before. Maybe I should click the link to the documentation to see what that means. In this case, given the number of objects, because it's charged on a per object basis, our rough calculation was that it was about $100,000 to push that button. I've never pushed a $100,000 button in the AWS console. I don't know if anybody else has. And it's a rare organization that kind of empowers their frontline folks to do that. So then that became an escalation. And I think that if you talk about it long enough, the people who actually created the problem can leave the company and you can have new people still there, thus proving that your S3 bill will only ever increase. So infrastructure as code is just YAML, right? It's just a flat file. It's just a little bit of text or just a little bit of description of how the infrastructure is going to run, right? What could go wrong? So, did we have tests for it? Well, we were testing the service, right? So that's going to test the infrastructure. Okay. We were doing infrastructure as code. We were doing CI/CD. We were doing all the things. We felt awesome. Yeah. We found some really subtle problems specifically with step functions and the states language. Embedding states language in your infrastructure as code, suddenly you're no longer describing infrastructure, you also have flow control, and you also have application logic that's now bound into those infrastructure as code artifacts. We had problems orchestrating the changing of schema on response messages. We kind of had to do a two-step transition, right? And so then you now have a strict ordering on certain transitions. It slows you down, makes things more difficult. We also had trouble running tests that would test not just the known error paths, but trying to test unknown error paths in those step functions or state machines. So, other one, somewhat embarrassing, was the VPC template that we had. We thought we were running multi-availability zones, as you should, right? That's what everybody tells you to do. So, however, if your parameters, which aren't actually in the template, right? But it was the parameter file that specified the AZs, and if they both say to go launch that subnet in the same availability zone, the template will just launch it in the same availability zone, which means you get to find out that you have a bug when it fails in production. So, or a DR test. Actually, in our case, we did catch it with a DR test. So that was somewhat embarrassing. Other ways that we've seen this fault. I mean, I don't know, does anybody CloudFormation shop here? Everybody's all on Terraform and what. I have struggled with these CloudFormation tools. They never seem to live up to the promise here. Yeah, these other things that, are you testing for the dog that doesn't bark with logs not getting generated and the like? And Lambda and CloudWatch, I don't know who designed that integration, that when a Lambda gets created, it's automatically going to create a log group. Great. Well, we don't know how long you want your data stored, so default is infinite retention. And so once you create your Lambda, you've created a log group, and you now can't pull that into your infrastructure as code. So you're going to have to go change the name of the Lambda, or you're going to, at the time you create your Lambda, you're going to have to go in advance and create a log group that has a name that you know Lambda will be going and looking for, and set the lifecycle policy or the retention policy on that CloudWatch group. Other things that seems like people have done to solve this is the CloudWatch team helpfully now has like a select all button in the console, so you can apply a lifecycle policy to all, which I don't know. Somehow the message didn't get back, I think. So with Lambda, who's running Lambdas in production? Yeah? Native runtimes? I'm seeing some nods. Okay. I think they're awesome. Native runtimes, I feel like, are the best option. They just have some sharp edges. I don't know if anybody got hit with Python getting unbundled or unvendored. Sorry, the Python SDK unvendoring the requests library. So Amazon, they will change the SDK version on you. Even you're running the same version of the runtime, there'll be AWS SDK changes underneath that you don't always get notice of. And it's also problematic because Node, if you're running that SDK, the V2 one is 75 megabytes. So you're already consuming 30% of your build, your bundle budget. And then at least my experience is the custom image Lambdas, which is the sort of the standard solution for this. You get significantly longer cold start times, and you really have like that slower startup. So like you kind of, I don't know, you got to pick your sharp edges here, I guess. Okay, serverless can scale on demand. Since we were serverless, we were just going to launch this collection of CloudFormation templates for all the microservices we were doing. And as we started to go from single microservice to collection of microservices till collection of collections, a single branch push could trigger 20 or 30 CloudFormation stacks getting launched in the dev account. This is great when it works, but it also was problematic on the control plane. AWS has, of course, quotas and limits, and one of them that we found was these control plane limits with particularly this 2 custom domains per minute launching. I mean, you may find that you have other rate limits that you hit if you try to launch 20 CloudFormations at the same time. Also, I don't fully understand the pricing on config, but it seems like it's, again, a service that just always makes more money. And so config on, best practice, seems to just chew through cache. So also the launch times are somewhat problematic. Okay, well, at least serverless is secure, right? No? Okay. Yeah, the classic API gateway, fronting Lambda, works in dev test prod, everything's great. Woo! Yeah, make sure that when your developers are copying and pasting code around, that they're copying and pasting good code around. And if you have a star in that API gateway principle that it's allowed, who's allowed to invoke that Lambda, you could be allowing any API gateway resource to invoke your Lambda. Yeah, this was, again, something we caught in an architectural review, but yeah, somewhat concerning. So I'm Kam Lasater, founder of Cyclic. We're a Node.js serverless infrastructure from code platform, so launch your services easily. Our first foray is to let individual developers launch their services and iterate quickly. And so this is some of the stories of my failure over the last few years. You can reach me on email, Twitter. Happy to hear yours, maybe at the open tables or sometime over lunch or the like. So come say hello. I'll be around. All righty, cheers. Thank you.